Hello, and welcome back to another segment of Terminating Low Voltage Cables. I'm Ron with Ideal, and again, welcome to my channel. Now, this is part 2 of a 2-part series that's going to talk about coaxial cable. Now, part 1, if you haven't checked it out first, you might want to, because we talk a lot about the design of the cabling, where it came from, and how it's constructed. Now, in part 2 here, I'm going to give you a little bit more of a close-up of what the cable looks like and identify the different parts for you a little bit better. And then we'll talk a lot about installation tips that you might want to follow so you don't ruin the wire in the process of putting it in. Now, in video applications in homes, we typically use RG59, RG6, and RG6 quad. As a general rule, RG59 is no longer really used by the satellite and cable TV companies. Now, we still see it in closed-circuit TVs and some other applications, but RG6 and RG6 quad is what we use. All these wires have the same basic shape and construction to them, and again, they're all 75 ohms, and so they're all interchangeable as well. It's just that there's more loss associated with one, or better shielding. And in the case of RG6 quad, it's got that dual layer of foil and braids that give us that extra shielding. And again, I'd use that if I was concerned about interference from radio stations, TV stations, or some other source of interference. So again, the quad is just double shielded. So let's take a quick look at what the construction of this wire actually looks like, and then I'll get into the installation tips that you might want to follow. Here is a close-up of the actual RG6 cable. And when we look at the cable itself, and we strip it and prep it for putting a connector on the end of it, we need to do look in that 2-step strip. Look that up on the channel. And we will need to expose some of this center conductor. Now, RG6, this is going to be usually 18 gauge. RG59 is usually like a 20, maybe 22 gauge, and usually has more loss associated because the conductor is smaller. But this, again, is copper-coated steel, as we discussed earlier in part 1 of the video. And then we have the white dielectric underneath that, and then we have on the outside here an outer jacket, and then we remove that outer jacket. That exposes the second conductor to cabling, which is this braiding that we see, that, as we said, you can get in all types of different materials, and amount of braiding is covering, again, 60%, 40% braid, and then that exposes a foil underneath that. And again, the foil blocks high frequency energy. The braid takes out low frequency, so or interference, I should say. And when you look at the foil, it'll be overlapped someplace, but it's a continuous shield all the way around the cabling. Now, the difference between that and RG6 quad is that the RG6 quad will have an extra layer of braid. So when I strip the outer jacket off, there'll be a first layer of braiding. But then, if I find the overlap of the first layer of foil, I can find that and peel that out. And when I do, again, quad shield coax connectors, we need to remove this second layer of foil we find inside the cabling, and then that exposes the bottom layer of braid that during the termination process we would actually fold back as well. And again, look at the channel, look at the termination techniques used on all the F connectors that we have. And then we have the next layer, the first layer of foil on the bottom here next to the dielectric, and again the same center conductor as you would find again in RG6. And again, RG6, RG59, RG6 quad, they're all interchangeable because they're 75 ohm cables, but that's a close-up view of the cable itself. And again, we prefer to have a nice clean looking strip like this where there's nothing on the center conductor, and it's a good clean looking strip. So there you go, and in the next segment we'll talk a little bit about how you actually install that wire and some installation tips. Well, welcome back. In this portion, I'm going to talk a little bit about actually how to install that coaxial cable that you're going to pull through them walls and get that great video out of. And when you look at pulling wire and installing wire, one of the first things we got to talk about is pulling tensions or pulling strength that you can actually apply to the wire. Because again, if we throw several hundred pounds of weight against the wire, it's no longer obviously be the same shape or even maybe even gauge of wire. So there's a limit on that. And of course, we have two basic types of conductors in the industry. We have something abbreviated as copper-coated steel, which we've talked about. The pulling tension on that is 75 pounds of force. It can be applied to the cabling. At least that's the recommendation. Nobody measures this, but that's one of the things we're looking for. You know when you're applying too much. And the other conductor we might have is just a straight copper conductor. And copper conductors, 18 gauge RG6, the recommendation is 35 pounds. Okay? And so that's pulling tensions. Okay? Now obviously as we route the wire through walls, we've got to bend it around whatever. So bending radiuses are based on the size of the wire. So it'll be so many times size the diameter of the cabling. Now RG6 is about 1/4 inch in diameter. And as we're pulling the wire through walls, again we're pulling the cable, we tell you no more than 20 times the diameter of the wire. So in a RG6, a 20 diameter loop is about a 5-inch loop for us, okay? And once we get it where we want to, we can get it down and kind of fit it where we need it to be, or what we refer to as dressing the cable. They can let us get down to a 10-time diameter loop. So once we get dress the cable, we can get down to a 10-time diameter loop, okay? And that's the tightest they want you to bend that cable. Because again, anytime you deform the shape of the wire, you're messing with this 75 ohms of impedance that the wire is supposed to be. Now, we always want to leave a little slack at the outlets because we occasionally might have to come in here and re-terminate something, which over time we probably will. It's one of the reasons why we've gone to those compression coax connectors because of the water tightness in them. But the recommendations according to the standards are that we leave 8 to 12 inches of slack at an outlet. Now, when we're using outlets here and putting outlet boxes in, low voltage does not require back boxes according to the National Electric Code, and so that's the ones we like to use. And the reason is because a lot of people will take this 8 to 12 inches and of course wad that up and shove it inside your box, which is of course violating all of our bend radiuses that we prefer not to do. So again, outlet boxes can be the backless type. Now here's a great one, separation from power, because I hear all kinds of numbers out there and recommendations. And the only thing that is law that you have to follow when you're installing wire is, of course, the National Electric Code. And the NEC states that, if you look at Articles 800, that it will state that low voltage wires, as a general rule, should be about 2 inches away from any other type of power cabling. And so 2 inches. Now, and if we ever cross power wires, we'd like to do it at a right angle or perpendicular, because again, these magnetic fields are crossing here. We'd like to do cross at right angles. That's why we don't like to run alongside of a power line for really long distances. But again, the NEC says as long as you're 2 inches, you're cool. Now, there are times when this is fine, and you know what? The best answer to give people when they're routing cables is as far away as you can get it. And if you look at other recommendations by other folks, like there's called a standard for residential wiring called 570B. It would suggest 6 inches is what it would suggest. Okay, but again, as far away as you can get it, best answer. And when we pull the wire, we're not kinking the cable around whatever it might be. I think it's funny. You look at a lot of folks will come out of a first-story wall, go right, because they want to put an outlet in their upstairs bedroom, so they go out the wall on the first floor someplace and go up the side of the house, and of course then they come in the side of the house, and of course they're trying to hide that wire on the side of the house, so they put a pretty good sharp bend in there, and of course it comes through the wall and comes right down to where probably the baseboard is, because we're just going to run this right along the baseboard. Again, I'm not a great DIY guy, right? Then I'm going to bend it onto the baseboard, make it nice, and I'm going to again hide it into the baseboard. Of course, the first door jamb you come to, you're going to come up and give it a pretty good bend to hide it into that little door jamb. And of course, then I'm going to come up the top of the door jamb and give that a pretty bend and come across the top. And you can kind of see where this is going. And then eventually, we'll get to an outlet someplace in this room. This is bad. You got to understand, this pipe is this big, and 30 years ago we had a little bit of information going on the pipe, and the cable could support that. As things have gone and we're filling this pipe like we never have, again, we're changing the 75 ohms of the cabling. We really mean don't kink the cable today. Romex staples, they were what we used for years and years, and I'm going to tell you that you can use a Romex staple as long as you're really careful and don't hit the wire with the hammer, not the staple itself, and don't pinch the living heck out of the wire with the staple. But as a general rule, we don't use them no more. We've got those plastic staples, those half-mounted moon ones. You can shoot through a staple gun, or if you are using a device, with a screw, that's fine too. But there are other ways besides Romex staples to attach wires to wood members within a building or whatever it might be. Cable ties are fine too. Just make sure that you don't cinch the living daylights out of the bundle when you cable tie it to something. And then the last thing is properly grounding systems. And I'm going to tell you that ground problems in buildings, you know what the #1 cause of bad grounding is? And the answer is loose connections. And I'm sure you run outside every once in a great while and tighten that lug that this cable system or satellite system might have happened to have been attached to once in a great while, and nobody does that. Or you go inside and tighten any of the other connections up, and or look for corrosion and things like that. There's a lot of things that can cause bad grounding. It was caused by bad video, and by code, National Electric Code, you've got to ground all these wires as they enter the building. And today we have several different type of grounding bridges that might be utilized on the side of the home. Or again, we can go out to maybe a ground rod on the side of the home. So there you go. There's some installation tips that I would ask you to follow as you install your category cables. And thanks for coming to another segment of Terminating Low Voltage Wires. Again, I'm Ron with Ideal, and we'll see you next time.